Hello, today I would like to present my proposal titled FYP proposal titled Sustainable JATROPHA Membrane with Carbon Dots in Removal of Copper from Aqueous Solution Process. My name is UMAR Adam bin Majid, metric number 1902T3. Before I start my presentation, I would like to introduce you to my abbreviation used inside this presentation. GPU JATROPHA polyurethane membrane, EGO epoxide crude JATROPHA oil, GOL JATROPHA oil-based polyol, HDI hexamethylene diisocyanate, CB is carbon dots. So the background of my OFYP project, there has been increasing interest in exploring environment-friendly membrane filtration for water treatment from green and sustainable alternative material. This scenario has begun to change the conventional approach toward inorganic sources by exploiting biodegradable and fully sustainable material, such as from plant and microorganisms due to the multitude use of petroleum-derived material. JATROPHA acrylicus, which belong to the Apricaceae Euprobiaceae family, has gained attention in industry in terms of environmental, agricultural, energy production, pharmaceutical, and other purposes. Besides that, JATROPHA oil also been used for replacement for fossil fuel to minimize greenhouse effect emission, making candles, soap, cosmetics, surface coating, and also its seed extract and press cake have been used for water treatment for a coagulation process in treating palm oil mill effluent. In recent years, JATROPHA oil-derived material have been utilized in producing biodegradable film for packaging, insulation, furniture, and so on. So JATROPHA oil has been reported to contain high iodine level, which indicate amount of unsaturated double bond in the fatty acid, which we can use to modify it into other useful substances. For the research aim and objective, the aim is to study the potential sustainable JATROPHA oil-based polyurethane with carbon dots membrane to filter heavy metal in aqueous solution. The objective are to fabricate and characterize JATROPHA oil-based polyurethane with carbon dots membrane and to study the performance of pristine JATROPHA polyurethane membrane and also JPU with carbon dots for heavy metal removal. In our case is copper. Literature review for our project from Crimea saying that material from hydroselected vegetable oil have been spotlight for synthesis of polyurethane, saying that JATROPHA oil can be used to produce polyurethane. Alam et al. 2014 saying that polyurethanes are fabricated by polyaddition reaction amongst isocyanates, alcohol, and different compound consist of external hydrogen atom. In terms of our project, the isocyanates used is hexamethylene diisocyanate because it is the most simple structured isocyanate. It is a single line carbon. Because single line carbon would be more easily to be decayed to be in the environment compared to other isocyanate that has much complex structure. Sahu said polyaddition of soft segmental polyol group which hard segmental isocyanate group are forming the block polymers of polyurethane with the presence of different chain extenders and catalysts. The most likable reaction in fabricating the biopolyurethane. Marlina et al. 2017, Nyamplung seed oil-based polyurethane membrane is fabricated for heavy metal removal from water such as mercury, showing that oil-based from seed oil-based polyurethane from Nyamplung can be used for heavy metal removal, in this case mercury. Salah et al. 2017 saying that JATROPHA oil has three glass wrap structure that is mainly containing 78.9% of unsaturated percentage by the reason of oleic and lean oleic acid in the structure, cultivating phosphor carbonization. This spot of oleic and lean oleic acid is used for modification to change it into polyol and further process to produce polyurethane. In this project, our carbon dots is synthesis from orange juice, Citrus nobilis deliciosa, which have the main component of sucrose, sugar for carbon source, sucrose, glucose, fructose, and also they have citric acid and ascorbic acid. And they are also rich in surface oxygen functional group, which has carbon dots size is below than 10 nanometers. So by adding this carbon dots into the polyurethane membrane will improve the properties, the hydrophilicity, and also the mechanical strength. These properties will help with the process of filtration. Problem statement: resource depletion of petroleum, other raw material in fabrication of polyurethane materials have become a rising issue globally among consumers, commonly on environmental. The fouling effect degrades the effectiveness of membrane filtration, and the high usage of inorganic synthetic polymer membrane give impact to the environment in terms of the safety issue. Based on this problem, we want to create a biopolymer membrane by using biomaterial to reduce the use of inorganic polymers such as JPU and CDs that use biomaterial to produce a biodegradable synthetic polymer membrane that is environmentally and could be decayed. Methodology. So for our produced membrane, we have characterization test, which is thermogravimetric analysis, which tests the degradation of the membrane, DSC differential. Where is it? DSC's differential scanning calorimetry, which tests the temperature before the polyurethane melt. FTR Fourier transform infrared spectroscopy, which classify the type of functional group exists in the sample in the polyurethane based on the peak of the data produced. FISM plus contact angle test, field emission scanning electromicroscopy, which tests the which you can see the morphology of the produced polyurethane, which we can see the angle of when water droplet is dropped on top of the membrane. We can see whether it's hydrophobic or hydrophilic, which when the contact angle is more than 90-degree angle, so it's considered hydrophobic. So we want to make the polyurethane membrane will have less contact angle towards water, so we denote that it has a better hydrophilicity. Next is zeta potential, which to identify the charge of the carbon dots, because the filtration process, our copper, which have charge, 2+ charge, if our polyurethane membrane have negatively charged, then it will attract each other, then it would affect the performance of the filtration process. Next is carbon dot synthesis. We use what's been have in one-step synthesis of highly luminescent carbon dots. So just using orange juice, using the hydrothermal carbonization at a temperature 120 Celsius, we can produce carbon dot synthesis. We can produce carbon dot. Next, for JATROPHA pristine membrane synthesis, we have three main process: epoxidation, ring opening process, and polyaddition. For epoxidation, start with 3 net flux, water bath, and stirrer is arranged. 90 RPM for stirrer is set. 65% Celsius of water bath. In addition was hydroperoxide, dropping of hydroperoxide into the mixture of acetic acid, ambulate catalyst, and crude JATROPHA oil. And then the temperature is increased gradually to 75% and being left for 5 hours. This epoxidation process is to modify the double bond between carbon to add an oxygen particle, so it would be a triangular structure of carbon and oxygen. Then is epoxidation extraction, which have hot and cold hot water addition. So 90 degrees Celsius DC water and then cool water and left overnight for 10 minutes, and 90 Celsius water for 9 minutes, and then it was quenched with N2SO4 and being let at 80 Celsius for 12 hours. Next is ring opening process. Ring opening process is the process of addition of OH to open up this triangular structure and 8 hydroxyl functional group inside the structure. So we start with 3 net flux, water bath and stirrer is prepared. Molar ratio of methanol to water to 5 to 1, 10% weight ratio of water to epoxy JATROPHA oil, H2SO4 as catalyst with 0.3 weight percentage total mixture. Sodium carbonate is used to quench the reaction, which builds a strong acid neutralization calculation, and product is lead to ambient temperature. So next is poly addition process. We have JATROPHA oil polyol ratio with hydro hexamethylene dioxycyanate. We have four different ratio. So we prepare the solution by stirring at 600 rpm between the temperature of 90 to 100. We let the polymerization time process polymerization at 1 hour. So phase inversion, after the solution is been thick like solution, then we cast the polyurethane into a mold so we cast it on cast it like butter, and we let it cure at 150 to 145 Celsius for 8 hours. And then when the polyurethane membrane is dried, it's produced a foam sheet exfoliated into flowing water using spatula. So the application we use for filtration process, we testing on the flux of the pure water rate produced and the rejection rate of the copper particle. Aqueous solution with copper pollution flow countercurrently with the membrane at different condition to find the optimum operation condition. So this is our example of our data that maybe we can produce we starting at 100, then we try different pressure 105, and then maybe in this case we find the better performance at 2 bar pressure, and then we change the concentration of copper, and then also we change the temperature of the